Yeah. I did the other two problems, but I'm just going to redo these because I checked the Prob1 day, and there are a few corrections that might be preferable. Um, so let's go ahead and re-enter all this stuff. Yeah, doing the same thing, adding all the components. You know. Then again, we're going to select probably NRTL. This one, let's go to the simulation. So we need to use a separator for this first one. And we're gonna put on the feed string. And again, just a little waste. I'm gonna ignore the energy string for now. But let's see, the feed vapor phase fraction, since this one says that the feed is 40% vaporized. We put 4 here. And on the composition, we'll move this to, again, make it the same ones we were doing before. So 0.3, 0.2, 0.15, and 0.35. That should be 5. Yeah. And then we found the temperature from earlier was, see, this one was water, right? That was just 40%. Sorry, 101 thing. And the flow rate was, let's just assume 100. Yeah, so there we go. And that should be it for that one. And then in the distillate stream, I think they wanted us to check the comps. Actually, let me look at that inside here to do that. Yeah, so these are all the, I'm just gonna take a screenshot of this for the report later. Emissions there. And the compositions. So this should be the methanol. The phases. Yeah, so I think the distillate, let's check this. Yeah, okay. So this one should be a, change this. I think these compositions are right. No, because XA is methanol, that's too high. 80% food. Bring this back up. Let's put this one. So if it's, let's put, no, this should be right. Sorry, my notifications. Yeah, and we got, there's something still wrong here. maybe if I, it's weird because this thing should have been higher if the feed was at this temperature. Well, that's for the temperature composition of both phases. Oh, is this it? This might be it. Yeah, okay, this one looks more. No, so it doesn't. There's a fake liquid and vapor phase here. 6, 7. That doesn't look right. 101. Maybe if I do it reverse. That's a little closer. Okay, this one looks more right. I think I had to change the temp here. Yeah. Yes, I think I actually had to back calculate from the 40% vapor distillation in order for that to happen. What temperature was needed at the top. So I already put in 100 arbitrarily, but I think if I do, like if this is initially comes in at 0, maybe I shouldn't specify that one actually. Right. So if the distillate's at 100 degrees Celsius, these fractions should be really close to that. Okay. Yeah, and that's like pretty close. 0.08, 0.09 seems about right. 0.13, 0.68. Yeah, and those are what's found in the distillate at 100 degrees Celsius. Okay. So let me get rid of this. And then for the second one, we use the same feed, but I think for the actual distillation column, let's insert this thing here. Let me just go to that second problem real quick. I'm sad. Since it is. Yeah. Okay, I think the first two were good. We just needed to sort of redo that because this pressure was wrong. Let's assume total distillate waste 10 stages is fine. What am I missing? So all those things in the book quickly here. And then what I did wrong was that this should be, the condenser pressure should be lower than this because of liquid on the bottom. It's just going to be. There needs to be a pressure gradient across the distillation column or it won't work. So that should be fine. Should be fine. We're not going to put in a certain ratio yet. So then we can go to monitor. We can put the reflux ratio at 3 because that was the operating one. And instead of doing the distillate rate, let's put in a spec for the 95% methanol like we did originally. So the stage out of the condenser should be, I think I said total reflux, so liquid. Spec value, 5 methanol. And let me check that to make sure that's all good. Yeah, And then we're going to need the, what else is it giving us here? Let's see. What's production rate, distillate rate? I still need one more here. What am I missing? Maybe because I didn't specify the temperature in here. Yeah, so if this is vapor, it's 1.1. This means it's subcrude liquid. So I think I had to put the temperature to like 55 or something. Right. This should be unconverged now. Then we have 0 degrees of freedom. So let's see if it solves there. Yeah, it's taking a while. It's even getting pretty close to 95. There. Reflux ratio is 3. Let me try adding a few more stages. Maybe I could make the pressure gradient a little more too. The problem does assume that we have the minimum number of stages to be like, actually it's at 16. Move to 14 just to get it fancier. Yeah, I think some of our secondary stuff is not being good. Yeah, there we go. So when I set it to 16, which is what I was supposed to find for the minimum number of stages for that problem, looks like it's solved out. So for a feed of 100, this actually says mole per hour, but this one was in kilomoles per hour. So we could just scale it down and it'll be the same. So the composition and amounts of the distillate on the bottom is going to worksheet. It's going to compositions. So yeah, when I set this up, I guess I set this up using the bottom part. We have these compositions, the distillate feed in the waste stream, and then also these conditions for the same thing. Then top and bottom temperatures are going to be, yeah, we already set it to total reflux, so these will be the top and bottom temperatures, which is fine. And for, I think all I need to do left actually is just add the water if you wanted to do that. So let's just go back and the properties real quick. Go back to the simulation. Go back to the feed. Add a comp of water here. That should be normalized. Yeah, okay. And we're basically gonna have to resolve here. So it's not going. And we need a few more stages if we have the water. I don't know why my Screen is being there. And then face this out. Yeah, it's coming in pretty cold. Let me see what happens bad in this stage real quick. Let's run that. Solves here. Looks like our here. We're deleting it. Fine. Or maybe I should take the distillate rate to be fine minimum and free trade location. So can I pull stop that and then add let me see if I could minimize it by 2 fractions. Yeah. I think this one should be liquid coming out. So we're gonna set that up. Set this there instead of that way. And there you go. That one converged. So our minimum reflex ratio for this type of thing was 3.6, which is fine. And then we have the column temperatures again, which I'll screenshot for the part 2. And again, the compositions, which haven't really changed a super amount. We saw the same methanol stuff, or methanol concentrations, top and bottom. Yeah, and I think that was good. All we need to do, all the corrections. So